Do you ever have the need to debug CAN interfaces and buses? Oscilloscopes are a great tool to allow you not only to see the decoded frames and packets, but also to correlate the electrical signals in real time. The Rohde Schwarz MX04 oscilloscopes allow you to do this with its powerful serial trigger and decode capabilities. Let's have a look. Here I have, with the DUT connected, a CAN interface that's been captured with the differential probe on channel 1. To enable a decode of this bus, all I have to do is to go at the bottom and click on the bus and choose the particular protocol type. Now here I can choose between different standards, so let's go ahead and choose CAN. And as this is a differential signal, I can go ahead and say that this is a CAN high signal. The next step is to choose the nominal bit rate, and for this I know it's about 50 kilobits per second. And the final setting that I would need to do is in fact the threshold. So this is probably the most important setting that you have on a scope. And here I can go ahead and set it to be about 1.2 volts, which is about right in the middle of that waveform. Let's go back into our CAN setup, and I should now be able to enable the CAN bus decoding. And as you can see in the background, we've now got color-coded bits that are being displayed on the screen. So let's go ahead and take a single shot, and as you can see, we can see the CAN frame nicely correlated with the electrical signals that we have. All the CAN bus data is color-coded so that you know which different frame types are there in that stream of data. Now at the moment, the scope is running and triggering on the edge of the signal. This doesn't give us too much information of the CAN bus data itself. So to allow you to actually trigger on the actual data that we're seeing, the CAN setup here allows me to go into the trigger settings, and I can go into the specific trigger conditions and thereby define a particular type for my CAN bus. So right now I'm just triggering on the start of frame, but I can also go into, say for example, an identifier and then set a particular identifier for this. So I know for my stream here, I have 11 bit of data, and I can go into here and enable 064 to be the start of my capture of this signal. And as you can see, it's triggering exactly on this particular 064 identifier. Now, this allows me to see and enable a very easily a trigger condition. This also allows you to do various different trigger types as well, like different error conditions or different frames and so on, to allow you to really debug what might be the problems on your CAN bus signal. The MX04 also has really deep memory. So it has about 400 megapoints of memory as standard and optionally about 800 megapoints of data. That allows you to capture large amounts of data in time. Let's see how this looks like for a CAN bus. So I'm going to go ahead and take a capture of about 2 seconds worth, and let's go ahead and press a single shot, and it triggers, and there you can see my decoded data on the top and my electrical signal at the bottom. To look at this in more detail, I can just enable a zoom window, and again with my finger I can just draw a box, and I can see again my electrical signal and also the decoded frames. So this is one way of visualizing it. The other more perhaps easier way to do it as well is to enable something that we call as decode table. So whatever you're capturing here is now then displayed as a full decoded table that allows you to see the full data in its fashion. So here you can see the full 2 seconds worth of data in this table here. And what's nice is it also shows you all the details of the frame and also a timestamp based on where the trigger point is. So now if I actually click on one of these frames, even the zoom window also would follow these frames, if you like, to actually get you more details and help you debug exactly what might be wrong with the CAN signal. The MX04 allows you powerful serial trigger and decode capabilities, all done in hardware to accelerate the capture rate and so forth. Check out the MX04 in your lab, see the difference.